Today's lecture, we are going to see this physical geological topics one by one. And okay, fine. So we'll start with the ocean and sea. So if you see, the definition of a sea is an extensively developed continuous body of salt water having inland extension or impediment. So that is what we call it as a sea. But when you see, when we analyze a sea, it is not like that the continent suddenly ends and the sea starts. There is a transitional phase. So we are going to see that what is the transitional phase. For example, if you see, this is the cross profile of a land and the sea portion. This is how the topography it is slightly varying. The land where it meets the sea, that is sea level. Okay, so let us put the mark 0 there. That is the 0 means sea level, and to the depth of the sea, which goes around 5 kilometers. Okay, and the distance from the land, it goes around to 300 kilometers towards the ocean. Okay, so this is a rough general cross section of our sea and the land. And if you see the first part, if you start from the sea where it meets the continent, from there if you see, there is a gently sloping part of the land. Okay, so this gently sloping part of the land, we call it as a continental shelf. So this continental shelf comes here, and there is a sharp change in the slope, and it drastically increases, and this portion we call it as a continental slope. And in the continental slope, there are some areas where there is a little rise, that the slope is not continuing, the slope is reducing. That portion of the sea profile, we call it as a continental rise. And finally, it goes into the larger part, we call it as an abyssal plain, which is a almost flat bottom portion of the ocean. Correct? It is going now, this part, it is going into the oceanic part. And if you see this part starting from the continental portion or the continent to this kilometer around to 270 kilometers towards the ocean, this part we call it as a continental margin. Correct. So the waves, so if I talk about the sea, the major action of the sea, which is continuously coming towards the land, and there are number of erosion and depositional processes which is happening here in the part where the sea intersects with the land. And in this part also, same thing happens when the sea which flows from the waves which generating from the sea which abutting to the beach, there are number of processes, erosion depositional processes. Whereas in the same way, when the water from the river which goes into the sea is started depositing on the sea shelf or the continental slope or in the continental shelf part of the sea. So this is a general cross profile of our sea. Now, if you see that how these waves are generating, as you know that the sea waves are generated by disturbances on the surface of the sea water due to strong rushing wind, or it may be due to an earthquake, or it may be an attraction of sea water by sun and moon. That tides we must have heard about. Earthquakes which generates large waves, we call it as tsunami. And the normal waves what we are generating by the wind action, that is what we usually see on the seashore when we go to the beach. So this is the beach part. And the height of the waves which is coming to the sea, which depends on the profile of this part, which is that part is called the continental shelf part. So at what distance from the beach the waves breaks. For example, the waves which is generating from the ocean, it is moving towards the coast, and it which reaches, it is generating from the ocean, it is moving towards the coast. And while it is moving towards the coast, while it is reaching in this part, the depth of the wave which is generated in the ocean, where it comes here in this part, it drastically reduces. Okay, as a result, what happens? The wave breaks. this large waves which is generated on this part of the ocean, when it comes towards the coastal portion, it breaks. As a result, it creates large waves on this part. Okay, so this is the waves which is generating on the sea, on the beach purpose. So it all depends on that in which part the waves breaks. For example, in some of the beaches, if you go, you will see a very calm waves which is coming to the sea, as coming to the beach. But in some other areas, if you see, there is a rocky cliff, and where in this part, if you go, then there is a very strong waves which are coming to this. The reason for these strong waves, which is that the breaking of the waves which is happening which somewhere very near to the beach. Okay, so where here it breaks, it creates large waves, and it creates large high magnitude waves in the beach part. Correct. So this waves, when it moves, there are two type of movements. The first one, it is an oscillatory movement, the water which moves in circular orbit, and at the same time this water which moves in the forward direction. So that movement is called the translation movement, translatory movement. At the end, when it reaches the coast, then it spread and it goes back into the sea. So this process of movement of the current, this is the wave current, and if you see here, this is somewhere, this is the beach portion, this is the ocean portion, and this is the beach portion, and where this is the waves which are coming, and after these waves coming, which has moved to the beach, and it reached the maximum level, and then it moves back. And while moving back, there are a transitional movement on the beach. So this is actually the process which move the sand or the sediments which are available on the moon. This movement of the movement is called the longshore currents. Okay, so which is moving parallel to the beach. Okay, so the current which is the water which is moving backward to the sea, which called it is a rip current. Okay, so this longshore current or the lateral current, which is one wave which is coming this towards the beach, which divided into two currents. One is lateral current and the other one is the rip current. One moves parallel to the coast and other moves backside. So it is not exactly perpendicular, the waves are cutting the beach, but it is to an angle, and as a result there are number of different kind of movements of particles which happens on the seashore. So this is an aerial photograph of a wave which is coming, and it comes and now it is going back. Here we can see that the waves which are going back. Okay, so if you have observed this kind of movement, you must have observed this kind of movements in the beach terrains. Now if you see the action of this marine processes. Okay, so there are basically three different processes of erosions which does. First one is called a hydraulic action. Hydraulic action is nothing but the water which is transferred by the from the sea, which erodes the beach. Okay, only the water which is going to, if you see that there is a beach or a cliff, and this is the water which is coming, and when it comes here, which starting eroding from here. So this process of erosion which will produce some process of erosions here. So this erosion is only with the water. Now this water which is along with sediments. Now initially the water is only the reason for the erosion, but later on this water which is eroding the sediments, there will be some sediments which is suspended in the water. Now in this case what happens, the water along with the sediments which gives erosion, and this process we call it as a marine abrasion. Okay, So hydraulic action is the pure water which erodes, and the abrasion is what? Marine abrasion is what? Which along with the water there are fine sediments which are in suspension that also will create more erosion. Just for an example, if you take a cup of water and put the water on some rough surface and try to wash that surface, it will clean little bit, but if you put some fine grains of sand along with that water and clean the surface will clean better. Why? Because the fine grains which are there in the water which act as a more abrasion agent, and that creates more abrasion. Similarly, in this case also, when the erosion which is caused by hydraulic action compared to the abrasion is less, that means the hydraulic action will erode, but abrasion will do more amount of erosion. And the third portion, which is nothing but it is the corrosion process, and the corrosion process is the process of erosion produced by the chemical action. Okay, the water which is there in the sea, that they are mostly saline water, so that actually creates some amount of corrosion activities also during the process of marine erosion. So there are three processes of erosion. One is hydraulic action, that is only water which erodes the things, and the marine abrasion, which is water along with the suspended sediments which erodes, and the corrosion, which is basically the chemical action by the water. Now, how much effort, how much erosion these processes will do, that depends on the different parameters. Number one, it is the strength of the rock, what kind of rock it is, and how much is the strength of that rock. And third one, it is the slope, if it is gently sloping or if it is steeply sloping, or the height of the material or the depth of the thing, and the profile of the shoreline. Profile of the shoreline we have already discussed, that where it cuts the break, if the wave cutting is very closer towards the beach, then there would be a very strong waves, and that strong waves will be able to erode more. And depth of the rock, how much it is, how much height is there, and what is the slope. If it is a gently sloping, then the water will go slowly moving into the slope and it may erode less. But if it is a very steep sloping, then water will directly hit on the cliff and it will erode more. And the lithology means in what kind of rocks are there. If it is a simple loose rock type, then it will be very easy to erode. Or for example, if it is a rock types like sedimentary rocks, which sometimes be more fragile, so that would be very easy for to erode. Whereas in the case of a granite like igneous rocks, or a basalt, or a nice like metamorphic rocks, if it is present there, then that will be very difficult to erode the rock. So lithology also makes a major role, and the strength is somewhere it is related to the lithology, what kind of rock, which that also plays a major role in the factors which controlling the erosion. Now, as a process of this erosion, there are number of different landforms which are going to produce. So these are the common erosive features which are produced by the marine erosion. Number one is called headlands and bays. These headlands and bays are nothing but, for example, this was the older shoreline. What happens is the waves which are directly acting on this, and the rock types which are present in this part, which are relatively less strength, which are processed less strength. As a result, what happens? This part which eroded more compared to this part. So this portion which creates a wavy or an undulatory surface or a shoreline, which was earlier which was straight, but this portion eroded more compared to this portion. So this portion is called headland, and the eroded portion is called the bay. Okay, so second one, it is a sea cliff, and this part if you see, this is a sea cliff. What happened is the wind, the sea current or the waves which is directly coming and hitting on this part, it started eroding, and as a result it's eroded more and more. So this portion will be eroded more and more. Finally this will collapse, and this sea cliff will promise further forward, progress further forward. So this kind of processes are developed. Earlier this was on this level. Now we can see that it has moved back to this level. So this kind of cliffs can be produced because of the action of the waves. Terraces are nothing but if this here we are able to see only one level, but in some cases if it is going to erode this part more and this is completely gone, now what happens? So there would be two different levels. One level is here, so this is continuing up to here, and there is another layer. So this we call it as the terraces. Terraces means steps. So we'll get one step here, so we'll get another step here. So there will be two steps, one step and two steps. So this steps like feature what is producing will be called the wave cut terraces. So these are the major erosional features which are produced by a marine process. So now let us go to, now these are the erosional features. Similarly, there are number of depositional features. Deposition means erosion process what? Erosion process what? The sea waves or the currents which is removing some materials. Now when these materials are removed, this material needs to deposit somewhere. It has to put somewhere. It either has to take it into the sea and deposit on the abyssal plain, or it will deposit somewhere on the continental shelf or the continental slope, or it may deposit somewhere on the beach itself. So the features which are produced by the deposition of the marine process, which are basically called beaches, then spits and bars, and tambola. So ideally these are all sand size particles depositing. So this portion what we see here, this is called a beach. Okay. Spits and bars, these are the large deposits which are depositing within the channel, and tambola is a process or the form which is connecting to this. So this portion is called a tambola. So ideally this is a deposition of sediments by the process of waves, and which is connecting to an island. So this is called a the tombola. So this kind of terminologies, different terminologies are applicable for the deposition process. So that is one. And when the sediments are going much deeper into the part where in the abyssal plain, so we call that sediments which are depositing are oosas or pelagic deposits. Okay. So these are main deposition features. If you go through the details, there are number of more deposition features, and like lot of more deeper erosional features are also available. But as a civil engineer, what we are concentrating in this kind of understanding of a geomorphological feature of sea or ocean is that when we are going to do any kind of construction in this part, maybe it is a sea barrier, or maybe it is a port, or maybe it is some buildings we are going to construct. So this kind of this kind of landforms or the features what you are identifying from the field will help us to take a proper decision. Okay, so this is a construction of a building just in front of the sea. I have constructed a building here. Now you tell me, is this feature a safe one? If you are constructing it here, is it safe? It is not safe because of number of reasons. Because the below that we have a sea arc or a sea caves, which is technically unstable, and the sea here it is very high. See the height of the wave which is reaching here. This is very high waves which are coming to this part. So the erosion in this part is obviously going to be very high, and this erosion is going to continue, and in few years the part which is going to go to the sea, and if I am constructing something on this part, then that is not feasible for the construction. Correct. So that is one thing. And second thing, when we get some kind of, now for example, imagine here there is no waves here. The wave is right now not reaching up to this part. Okay, that means the sea is right now on this part. For example, let us take an example. Here this is a sea beach. Okay, and today when I see, the water is coming up to here only. So here what we are getting is a beach. Okay, this is a beach, and here what I see is this is the sea. Now water is now not reaching up to this part. But when I have a closer look into this part, and I have seen there are some sea cut erosive features here. There are some erosions here, erosive features, and these erosion features have identified that it is basically produced by the action of a wave. So what is the interpretation of this? The interpretation of this is that once upon a time the sea was coming up to this part and it produces these erosion features here. But today the sea level has gone down, so the sea is here. So this is a clear-cut indication of what? Indication of a sea level change. And there are number of techniques through which I can find out that in what age, what time, how many years before this cutting process were acting on this surface. So for example, if I assume that it is 10 years before the sea was coming up to this level, then considering this area for a construction is not a good idea, because it is merely a 10 years. This building what I'm going to construct here, this is not a good idea. But if I identify this and I got an age of 1000 years, 1000 years before it was coming, then it is okay. It is took around 1000 years to go back. So again, it may take 1000 years to come up. So that is fair, not bad. So this kind of understandings we get from the geomorphological features.